Hello, everyone. Welcome to MYCOM OSI's Autonomous Networks webinar. Let's move this along a little bit. Thank you very much for joining our webinar today, and we've got three great hosts for you to take you through the agenda you can see up on screen. We've got Chris from Omdia, who's going to kick things off for us, then my colleague Jithu from MYCOM OSI, and then Aygul from AWS, who will round things up before we have a little Q&A session at the end. Some orientation first. On the right-hand side, you should see a chat bar. Pop any questions in here that you may have, anything raised by the three presenters, and we'll answer those at the end of the session. You should also see some polls pop up on the screen throughout the webinar, some handouts and some call to actions. But really, with that, and with much further ado, I'm going to hand over to Chris from Omdia. Over to you, Chris.
Thank you, Jack. Hello, everyone. I'm Christoforos Sarantopoulos, Senior Analyst for Omdia. And let's go straight to the topic. I think the requirement for automation in telcos is becoming more apparent than ever. At this point, we have what I would say it's a triple pressure for telcos. On the one side, they have the pressure to become more autonomous in terms of managing their network because of the increasing complexity. It is, first of all, the cloudification of the network stack creates an environment that is completely new for, or was, at least when this effort started, completely new for CSPs. And they didn't have the exact skills to manage this whole a new cloudified network stack. On the other side, there is the no matter the investment that was done in 5G, we've seen that there was no increase in ARPUs for service providers. So it is an area that still remains to be monetized on their side. To do this, to increase their revenues, and this is the third pressure that I would describe is the need to provide services in a more on-demand fashion, something more that mimics what the hyperscalers offer, where you can just log into their environment and spin up a virtual machine and or services in an instance. So because of this, all of these things need to be dealt with automation. So in a recent research that in a survey research that we ran with Omdia I think it was last quarter, we asked a very straightforward question that was based on the TM forum definition of the autonomous levels. So in a scale of level 0, where that is manual operations, and level 5, that is fully autonomous operations, where would they think that their organization maps in different network domains? And you can see the responses here from 61 personnel that work either in the CTO office or in high research and innovation positions, or they lead the engineering teams. And what we see in our research, first of all, is less than half of the CSPs have moved beyond level 2 of automation, and this is where AI is used only or primarily for monitoring and recommendations rather than autonomous decision making. Now you can see that we have some responses that some outliers, level 4 and level 5, but personally I would take those with a pinch of salt, and I think they are over optimistic. From what we see, we don't think that any service providers have reached level 4 autonomous operations at this point. And what we see is that even among the leading operations in automation, progress still remains fragmented, and some of them have successfully managed to automate individual domains or individual use cases. like run self-optimization or transported ASDN, or even they can offer some service assurance in the core network that is AI based. But in true cross-domain scenarios, that is the ask for level 4. This remains very rare, and in our research, we've seen that only 28% of the operators have deployed a sort of multi-domain orchestration solutions. So there is a very big gap in multi-domain integration. Now, in the same research, in the same survey, we try to ask about what are the challenges that keep operators from advancing their automation efforts, interoperability and integration with existing networks and employee skill sets were on top, and by a huge difference to any other reasons. And it's clear that the first the first big roadblock is the legacy architectures and integration with them, with products that automate the network. And also there is skill shortages in the workforce. A third reason that I would personally add is the trust in artificial intelligence. So traditionally, network teams that have the knowledge and the skills to manage the network, and they have been doing successfully so for many years, feel that an automation system that is based on artificial intelligence can't be trusted to initially to give away their authority in the first place, and this makes complete sense. So we need to have this time period of cooperation between the two, let's say, forms of managing the network. First, the operational teams need to remain the final decision for some time. Now, going to our to how service assurance helps in this whole effort. For us, it's clear that the service assurance can play the role of the control loop in this closed loop automation story. Based on TM Forum's suggestion and to its phased approach to level 4 automation, we've seen, so it's a phase 1 and phase 2, where phase 1 is the coming years from now to 2027, and phase 2 is from 2028 to 2030. And there is a definition for what are the high value scenarios where that can be automated within this phase 1. The high value scenarios are defined as a combination of the operational value and the technology feasibility. And we see there that the service assurance is one prominent solution that can be brought to level 4 within this first phase. And there are two reasons for this. First of all, it's that service assurance solutions have the maturity to integrate with, I would say, with a minimal effort, but this is optimistic, but within a reasonable effort to integrate with this legacy or mixed architectures that exist in network environments in service providers, and also that can provide some easy wins in terms of providing this closed loop element. Also from a TM Forum survey, that we see that fault management and service assurance are the top priorities to automate within the coming years. So I would say they both fall under this whole traffic visibility and network visibility and monitoring and the assurance category. So So this is it, that customer experience is top priority, and service assurance is a key characteristic of level 4 autonomous networks. And with this, I will pass over to Jithu to continue with their view.
Thank you, Chris. Good day, everyone. I'm Jithu Raghavendran, Vice President for Telco Transformation and Automation/AI Solutions at MYCOM OSI. Pleased to be here. And thanks also to Chris for the great introduction through your market research results and insights on automation and autonomous networks. So, if I quickly progress into the next slide, where over the course of the next 15 minutes or so, I'll provide a summary of MYCOM's solutions to build autonomous networks using service assurance capabilities, and including a real demo of the use cases in production environments. I'll start off with a case study derived from MYCOM's value realization framework on how we evolve the autonomous network scoring from, let's say, level 1.8 to 3.3 and higher through proven results at a tier 1 CSP that's providing mobile, broadband, and enterprise services for their subscriber base. Firstly, we automated a range of mobile and broadband services in the service assurance domain by reducing over 85% in incident handling, automating over 600,000 person hours, taking into consideration over 300 service impacting alarms through our domain expertise embedded into our solutions, all leading to over $6 million worth of cost avoidance. We then actually progressed towards automating the enterprise services provided for their B2B customers by automating over 64,000 person hours and 99% of their workflow processes in their enterprise and IT network. Thirdly, through the introduction of automated customer impact analysis solutions, we were able to improve the MTTR, right, the mean time to repair, over 50% and reducing the customer complaints by over 90%. Then by progressing towards a zero-touch network operations center by reducing the incident handling times by over 97%, and auto remediation solutions were introduced, leading to a total of about $5 million worth of estimated savings costs-wise. Last but not the least, we have also been able to actually improve the operational efficiencies of the NOC and SOC teams by proactive incident reporting, by enhancing the quality of service, right? And close to about 2.5 times better network visibility, allowing all the workflows reassignment to high priority tasks to accelerate their FTTX and 5G rollouts, for instance. Next, I wanted to actually quickly touch on the autonomous network levels and mapping, as also heavily derived from the TMF standards as well. As Chris mentioned earlier, we adopt several industry standards, and more specifically, TMF recommendations, for example, IG 1326 on evolving transformation from level 2 to level 4/5, and have developed several assurance solutions to go from assistant operations and maintenance to highly autonomous capabilities in this journey. I'll summarize the blog so as to what it actually takes to go from one level to another, starting with level 0 to 1 with predefined configured rules for basic automation, moving to level 2 with selected autonomous actions for individual domains in a CSP network, to level 3 with high level of automation with intelligent correlation capabilities and remediation solutions would be introduced, to level 4, providing AI-based use cases for complicated cross-domain predictive analytics, including RCAs, to level 5 with intent-based automation capabilities as well. The bottom table actually indicates the impact of moving from one level to another. As you can see, the shift from personnel to automating the systems in their landscape, right? And so over here, we kind of actually introduce the MYCOM OSI's solutions that evolve to autonomous networks for CSPs, where we believe the key components in this journey as a must-have in the form of automated detection for L2, followed by auto correlation, auto ticketing, and auto dispatch for L3 and automated remediation for L3 to L4 with the AI-based remediation for a true L4 capability. We'll go through the details of each component in the coming slides. And as we move on, firstly, the auto detection of the network and service problems. The key pain points for CSPs like yourselves, where we clearly observed or the need for automated and accurate detection of service and network degradations, as well as faults without any human intervention. And how do we actually solve this? Firstly, it all starts with accurate representation of service models, which is actually described in the right bottom of these charts. Where we are able to actually kind of model the accurate version within the service modeling from resource to service to customer topology, and how we intelligently ingest the data sources such as performance management data, fault management data, probes, and topology, and enabling cross-domain correlations in each layer. This allows us to actually accurately identify the service KQI degradations, such as latency, throughput, application load times, and so on, to name a few, as well as network degradations such as the interface availability and round trip times, right? And as we actually move into the auto correlations, and this, this then leads to automated correlations of the network, service, and IT application data, which we commonly refer to as triple correlation. The key pain points for operators today is that there are disparate systems, disparate data sources for mobile, fixed, and enterprise services for non-consort teams. Find it extremely laborious to actually correlate all of this using a single system. This is where we are actually introducing all our automated workflows to do this triple correlation between the different layers, and also to actually kind of map the impact of one layer over the other in order to actually kind of do the drill downs through this autocorrelation, which acts as a key enabler. As you can see, some of the regions, the network AQIs, alarms, and TT, all in a single pane of glass, which actually is completely correlated with each other. Then we move into the auto ticketing parts of it, where the need to actually reduce huge volumes of tickets that are actually generated today, and also the accuracy of those tickets that are actually generated is actually one of the most important things, including automated ticketing. How do we actually sort of do this? The key thing is how we kind of bring everything together that we described before into automated generation of incident tickets with owner group, severity, root cause details, impacted network elements, as well as to actually create an escalation matrix, mapping some of the penalties with KQI breaches as well, which is also actually commonly used for our enterprise SLA management, where the auto ticketing to enterprise customers to comply with those SLAs is actually very critical. Then we move on into after you actually do the auto ticketing, how do we then auto dispatch for all the field engineering teams and so on? One of the key problems is because of the complexity of all this RCAs, especially in the last mile, which is where we actually see most of the money is being actually spent, right? And the customer premise equipments, time taken to actually inform all the field engineering teams, and the accurate information is actually critical. This is where the need to actually do automated dispatch to specific expert groups is actually very important, which will actually enable also automated remediation as well. How do we actually do it? So we've got automated auto dispatch solutions, then mapped from auto ticketing capabilities, which generates requests for dispatch and intelligently actually maps the field engineering teams based on the root cause analysis and the remediation actions, and are dispatched to various different third-party systems, APIs, integrations to various different on-field engineering dispatch systems as well. And then we get into the auto remediation part in order to actually do the automated fixing, where the RCA times are very long, and how do you actually enable the automated remediation through policies and so on. So where we've got like a strong policy engine, which automatically actually sort of sends the triggers, right, for remediation actions based on various different rules. And we've got a whole library of all these automated remediation capabilities for the various different domains. And based on the remediation actions, the system updates the status where the whole workflow then actually kicks if it's resolved, failed, no action required, and so on, right? And it actually has a good feedback loop in order for us to actually see if those fixes have actually made the specific improvements to the KQIs, as well as if it has operationally actually fixed those issues based on the customer experience. And lastly, the AI-based remediation leading to level 4. This is, in order to truly evolve from level 3 to level 4, an AI capability for performance forecasting and anomaly detection is absolutely required for us to actually help the field engineering teams, right, to identify the problems predictively rather than actually proactively as well, providing enough time to act before a service or customer issue is impacted. How do we actually do this? This is pretty much where, as you actually can see, the anomaly scores for customer network segment and KPIs are actually provided, very comprehensively by combining all the PM and FM data for performing the predictive modeling using machine learning models and discovery of specific network patterns and network segments. And then we also actually heavily use some of the large language models and Gen AI capabilities using natural language prompts. Also, this is pretty much where we harness the power of cloud native applications, including our partnership with AWS, integrating with Amazon Bedrock, for instance, providing foundational models such as Cloud 3 and Mistral. And Aygul will actually sort of provide later on through an excellent overview of how the cloud services allow CSPs to build automation in their environments. With our AI solutions, leverage network domain consolidation, data normalization, automation, and intelligent remediation of these issues, including strong Gen AI capabilities as well. So with that, I'll move into the next segment of this webinar, where I'll actually play a demo as you will see the solutions we describe all in action. Okay.
As the CTO of a large converged network, I want excellent quality of the network and services, and to save millions of dollars because of manual operations and uncorrelated data. I begin my day by checking my network and services health, scanning by telecom technology, network region or domain. Today, my dashboard has auto-detected a degradation in mobile and fixed broadband data services. I want to resolve the problem without human intervention. MYCOM OSI's automation solutions enable me to achieve 90% reduction in alarms, 85% reduction in time to repair, and hundreds of thousands of automated person hours every year. Let's see how. I see that the solution has activated an automated correlation between performance, fault, network topology, and incident data. This correlation of multiple data sources helps my team identify the root cause of service quality degradation for a specific technology, domain, and location. For example, to identify a RAN site degradation, the system looks up the key performance indicators and checks for any site network alarms. It also checks the site coverage and location. In a single view, I zoom into a network element for its performance, faults, and incidents. If a degradation is detected in the mobile core network, the system checks the service performance of each link. The engineer instantly visualizes the health of the core network nodes by checking KQIs, KPIs, and fault alarm status. This solution works for fixed broadband networks too. My operations team can monitor different fixed service types, links, and network elements, and assesses customer impact. For fixed broadband issues, individual customer-level performances and fiber cuts can be identified quickly. With a single click, engineers monitoring mobile, fixed, or enterprise networks check the root cause of alarms or performance degradation along with its impact on affected neighboring elements or on customers. Here you can see that the incident ticket information is available, so that my operations team is aware of automated actions that will follow. A service impact topology view based on service impacting alarms is also available for engineers if they want to see impacted neighboring network elements. After correlating information from multiple data sources, the automation solution correlates the alarms into a parent root cause alarm. This enables the operations team to work on a single alarm, instead of analyzing multiple child alarms, resulting in faster debugging. The next step is an automated incident ticket creation in a third-party tool. The automation solution automatically generates the tickets with owner information, root cause, network elements, and more. My operations engineers are supported through an auto-dispatch feature based on predefined rules and criteria. These dispatches can be emails, text, or WhatsApp messages. In the next step, the solution triggers automatic remediation actions based on predefined rules set by the operations team. When remediation actions are taken, the system updates the status of the correlated alarms. This informs my engineers that an automatic action has been taken and the problem is resolved. Now that 5 automated actions are complete, my telco network achieves a Level 3 autonomous network status. To evolve the network from Level 3 to 4, the solution utilizes its AI capability for performance forecasting and anomaly detection. This helps the operations engineers to identify problems before a network issue or alarm is raised, providing enough lead time to act before a service or customer is impacted. In this final step using AI, we achieve end-to-end automation of the network and service operations center, and the evolution to Level 4 autonomous network is complete.
Oh, sorry. With that, I'll actually pass this off to Aygul to go through the last part of this presentation. Over to you, Aygul.
Thank you, Jithu. Hi, I'm Aygul Aytuglu, OSS BSS Business Development Manager in AWS, focusing on the OSS area primarily. So with autonomous networks, we're looking to achieve self-service-based, fully digitized consumption models while improving our operational efficiencies with automation. So when we look at the business side, our main goal is to reduce cost to serve and be agile in introducing new services, especially while we're embarking on the B2B growth, and introducing new self-service consumption models for our customers and even internally. And when we look at those both are critical to gain competitive edge in our industry. And this requires streamlining and digitizing this entire process from network design, plan, build, to service delivery, operations, to monetization. And bridging the automation gap across this entire stream requires turning things into self-service models, as mentioned, for both internal teams and for our customers. And when we're talking about autonomous network operations, so we actually hiding the complexity and making the systems to manage themselves. Therefore, we also need to look into very important 2 aspects that I'll be talking about today. The first one is, what is the level of automation and autonomy we have while running dozens, even hundreds of applications that are providing those processes, those functionalities, right? Are we designing and running those applications with automation considerations in mind? And the second one is that we have seen in the demo as well, very important part, the AI aspect. How we are putting data and AI, now generative AI, at the center of those processes to enhance operations quality and efficiencies, and be able to create feedback loops in between systems to enable more data-driven, automated decision-making capabilities. How are we scaling that across the entire network and services as well? So not limiting ourselves with a very specific domain or very specific technology. So when we look at TM Forum, so they're emphasizing the importance of fully automated IT to achieve autonomous network operations. So we need to bridge the gap between the IT components and the way we're building the autonomous network operation functionalities. So are we providing agile, scalable foundation for the systems and processes for those hundreds of applications? And in order to enable this streamlined end-to-end service delivery, we need to make conscious architecture decisions when it comes to the deployment model. So this is something we need to really keep in mind. We're targeting to increase operational excellence, and this requires lean and highly automated processes at every level, not only at the functionality level, but for the entire stack. In the end, you're as fast as your slowest component and as agile as the least agile part of your processes. And so if we look at how we should enable that, so we need to be able to automatically scale up and down the resources based on the changing demand. So this will allow us more efficient use of resources, where we're really embarking on, where we're targeting to gain cost optimization. And if we look at the average OSS BSS IT utilizations, resource utilizations, this is less than 30%. And even in certain areas, in certain functionalities, it's less than 10%, because we have to consider the peak times, we have to dimension everything for those peak times. And this is causing inefficient cost structures. The other part is the resilience and performance, right? Operators benefit from inbuilt resilience and high availability when they run workloads on cloud, and of course, improved performance. So to give one example, we worked on modernizing a monolith assurance application. This was a bespoke application built by the operator, and which had no high availability. So after re-architecting that application on AWS, we observed 3 times improved performance and 48% reduced cost when running this application on AWS. And of course, we took it a step further by adding analytics capabilities, AI capabilities, and also we helped the customer even further simplify the management, what we call undifferentiated heavy lifting, to the cloud components by leveraging managed Kafka, managed Grafana kind of services from AWS. And when we accumulate those kind of improvements across the entire stack, this makes a very significant difference. So therefore, the deployment model, the conscious architectural decisions becomes very critical. And the agility is also a very important competitive differentiation. When we're making technology changes or process changes or introducing a new service, it's difficult to estimate the demand or making very precise technology decisions at the very beginning. So having the ability to growing as the demand grows, or being flexible in the technology changes based on the requirements, is very important in order to gain cost and gain flexibility and agility. So also, it's very important to highlight, as AWS, we're working with over 80 partners in the OSS and BSS domain on the deployment architecture reviews, applying cloud native principle into their applications, and pass those benefits to the operators together. And with MYCOM, we not only achieved the lean and cloud native architecture, so it's a very a lean architecture, I would say. So we have made a lot of iterations, and where we are at that stage is quite good. But also, like Jithu explained, we added intelligent capabilities with AI, machine learning, as well as generative AI. And so, of course, while talking about AI and generative AI, so the second important point that I mentioned is data and the analytics, AI part of it. So while transitioning towards autonomous networks level 5, this requires having AI at the core and the center of the operations and processes to achieve this intent-driven models. So augmenting data and AI into those complicated systems and processes at large scale goes hand in hand with the cloud-native architectures and cloud deployments. So we can't separate those two from each other. Again, as AWS, we're providing a complete set of services to unify data and create a way to manage the data in a consistent way. The way the data is stored, curated, structured, governed, analyzed, visualized becomes easier on cloud. And one of the important reasons of it is not only having access to a wide set of AWS services, but also leveraging the pace of innovation, the R&D investments that we're making in that area. Especially it's important when it comes to accessing the technology advancements like generative AI, which is a very fast-paced technology advancement all by itself. McKinsey estimates $140 to $180 billion productivity gains with the adoption of generative AI in the telecom industry. So we're already seeing some production deployments of several use cases. So one of which is creating a model that is trained with the operator's decades worth of network design documents in all kinds of different formats. And with that, helping the operator reducing the network design time by 30%, and achieving a consistent quality across the entire team, regardless of the experience level. And we worked with our partner on creating orchestration flow or optimization recommendations. And we worked with a network vendor, building a small language model with them, trained with their product documentation to help engineers on troubleshooting, configuration checks, configuration creations. Another one is network digital twins become highly popular in order to do impact management planning in a more streamlined way, so improving the quality of those activities. And what we worked with MYCOM, as Jithu mentioned, on Network Genie, a generative AI assistant for NOC SOC teams, which can be used also by the executives to have better understanding of what's going on the network side. And so our approach to generative AI has 3 layers. So this layered approach is important to understand how different components work together to enable AI-powered automation. So if we start with the bottom foundation layer, we provide underlying infrastructure, specialized hardware for training, running generative AI applications cost efficiently and with high performance. So cost efficiency becomes very important when we're talking about generative AI applications. So at the platform layer, we provide services to build generative AI applications and custom AI models. So with Amazon Bedrock, we provide API access to a wide range of models to use to compare the results and customize different models. And of course, another very important point is we provide guardrails to help filtering out hallucinations, so detecting PII data on prompts and responses of LLM to comply with the privacy considerations. And we provide security services like encryption for data at rest and in transit. And at the top layer, application layer, we provide ready-to-use generative AI solutions, such as Amazon Q for Developer, so which is helping developers by generating code, which is used by BT to improve their developer productivity. And so as AWS, we're providing a democratized access, so that's very important. So to this rapidly evolving technology, and we provide the right infrastructure options to gain cost efficiency and cost control. And lastly, so I would like to share generative AI maturity interactive tool, Gamut, that we built together with TM Forum. So I think the link will be shared. So Gamut is an AI maturity model assessment based on 6 pillars, built on the data from over 200 leading AI experts. And it's worthwhile to take a look into that if you haven't done it yet. And with that, I will hand back to Jack for the Q&A.
Thank you very much, Aygul. And well, thank you to all 3 of our presenters today. So we now veer into the Q&A part of the webinar. I hope you've all found the presentations interesting. If you've got any burning questions from our demo or from Chris's insights from Omdia, please do pop them in the chat box on the right-hand side. We've got a couple that we can ask right now. I think this one's going to be to you, Jithu. We did share a case study earlier on as you were presenting, an anonymized one, but can you elaborate on the use cases relating to closed loop automation in fixed and broadband networks a little bit more?
Yeah. Thanks, Jack. Okay, that's a good question. So I think the first thing is we actually did provide some impressive results that we've actually seen, kind of taking it all the way to like level 3 to 4 level automation, including the use of proactive identification and automatic remediation, as well as the augmentation of AI capabilities in it. So if you actually kind of zoom into some of those specific use cases within fixed broadband access and IP core, the need to actually kind of model service models across the end-to-end network in order to identify the impact on OLT, especially in the last mile, and the connected subscribers due to uplink issues is actually quite critical. And there is a lot of impacted passive equipment subscriber due to service degradation, and understanding that degradation of OLTs very quickly using the correlation of the different data sources, where lots of manual inventory sources we've actually automated, right? That's one case. And then lastly, leading to automated ticketing and dispatch across the subscriber base by taking into consideration the pre-aggregated routers, Metro Core, the OLT uplink, as well as actually looking at the fixed broadband for, it goes all the way, right? FT, fiber to the home, fiber to the premise, and so on and so forth. And in some cases, when you actually have converged operators actually offering triple play services and so on, this is where actually a single pane of glass is actually quite important to look at that uplink from OLT to P and to edge to core NCS related networks and so on. And then from an automated remediation perspective through machine learning techniques, we offer, the specific areas of remediation, including, the port resets, as well as when it actually also comes to specifically looking at the configuration parameter changes that we would automatically recommend in order to actually have those golden parameters is actually quite important. Everything actually is derived from our solutions catalog that we would actually offer to our customers, and that we have seen some impressive results with our customers, especially in the last mile.
Cool, thank you. I mean, that's a perfect link for me to put this call to action up. Here's one of our customers and some impressive results with them. It's just a little news item from earlier last year. I work with Globe in the Philippines. We do have some more questions coming through, which is great to see. I think we'll start at the top. Let's bring this one up on screen from James. What are the cloud deployment options available for MYCOM OSI's automation solutions, and do you support hybrid or on-prem deployments? Jithu, this is another one for you.
Yeah, so generally we do actually support both, container-based, cloud-native solutions, of course, which is our primary blueprint, as we actually mentioned, also with the partnership that we have established over the years with AWS. But having said that, it is also actually available as an on-prem solution for customers who are actually having private on-prem infra, and who would also actually like to kind of do migrations towards the public cloud, right? So we do offer hybrid capabilities for all our applications and solutions, depending on which size actually fits them.
Cool, thank you. I think we've got one that we can really ask to all three of you. So an Omdia, MYCOM OSI, and AWS question. Let's bring it up on screen. Is it necessary for an operator to go level 2, level 3, level 4 model, or can they skip a jump, like changing gears in old-fashioned cars, go from level 2 to level 4 by skipping level 3? Open to any of you to answer that one. Any experience there?
Would you like to go, Chris? Yeah.
Yeah, I could say obviously there is nothing to stop anyone from jumping from level 2 to level 4, right? In reality, I see, this type of efforts are not, that you completely wipe out your network and you put something else in place. It's, a continuous effort, and it has this sense of progression. So it's not like, it's more like an effort that you continue to build and expand your automation capabilities, and you reach a point that you say that, look, I have the capabilities that tick these boxes to define my network as level 4. It's, it's also a model. This autonomous network levels is a model that is built to depict or to simulate real network deployments. So in reality, I would say, it's always a continuous journey.
I think conscious of time, so we've probably got time for one more. Let's have a look what we had come through. We'll bring this one up. I guess this is another Jithu question. What improvements in mean time to R have been observed after implementing MYCOM OSI's automation solutions? Oh, you're on mute, Jithu.
Yeah, so I can take that one. Yeah, okay. So, I mean, across the range of mobile, fixed, and enterprise services, a key thing is, where we've actually been able to see over 60% improvements in mean time to identify, mean time to correlate, as well as mean time to dispatch and remediate is what we've actually seen, and which has actually led to directly 90% customer complaint reductions. So, we've been kind of like, over the years have actually kind of progressed that MTTR curve to over 70%, right, or the MTTX curves so far that we've been able to achieve.
Thank you very much. And then one more, maybe Aygul, will go to you for this one first, and then Jithu, if you've got any further points. I've just clicked answered before I brought it on screen. I'll read it out. What mechanisms are in place to ensure accuracy and reliability in automated decision-making, particularly when using Gen AI?
I think so guardrails becomes very important here. So for the input and output evaluation, so how we are just really making sure that we are having the right inputs and the outputs and how we're assessing them. And also still having human in the loop until gaining some level of confidence while using generative AI is still what we're seeing is maybe the safest way of adopting this technology within the operations.
And Jithu, any further points?
Yeah, I mean, Aygul has actually sort of answered that excellently, and I think when it comes to actually the Gen AI overlay, one of the things that we would obviously add on top of it is actually the prompt scheduling for persistent user sessions, as well as low latency, in order to actually get the automated remediated actions based on the prompt engineering and so on. With guardrail, as Aygul mentioned, it all actually kind of comes to the fore.
Thank you. So I guess I should say as well, we've got coming up next month, the Glastonbury of telcos and tech. We've got MWC. I think we're all going to be there in some form or another with stands or offices. So if any of you watching want to come and meet any of us there, just drop us a link after this webinar. I'm sure we're all willing to have some meetings. Thank you very much, Chris, Jithu, and Aygul for presenting in this webinar, and thanks to everyone that's come and followed us this morning. We can send out the deck if anyone's interested. We'll do a little follow-up email later on, as well as a live recording of the webinar. But once again, thank you for joining, and thank you to our presenters. Hope you all have a great day.
And thank you, Jack. Enjoyed that session with all the questions as well. Thank you.
Thank you.
Thank you.